Hello everybody, and welcome back to another video, another session of ours. Today we continuing with our sessions on linear programming. We have done the graphical method. We have done how to derive linear programming problems when they have given you things like tables, for example. Now today we want to take it a step further and look at how do you formulate linear programming problems when the question is a statement question like what we have on the screen there. So the question reads: the PC Tech company assembles and then tests two models of computers, Basic and XP. For the coming month, the company wants to decide how many of each model to assemble and then test. No computers are in inventory from the previous month, and because these models are going to be changed after this month, the company doesn't want to hold any inventory after this month. It believes the most it can sell this month are 600 basic and 1,200 XPs. Each basic sells for $300 and each XP sells for $450. The cost of component parts for a basic is $150. For an XP it is $225. Labor is required for assembly and testing. There are at most 10,000 assembly hours and 3,000 testing hours available. Each labor hour for assembling costs $11, and each labor hour for testing costs $15. Each basic requires 4 hours of assembling and 1 hour for testing, and each XP requires 6 hours of assembling and 2 hours of testing. PC Tech wants to know how many of each models it can produce, both to assemble and test, to maximize its net profit. But it cannot use more labor hours than are available, and it cannot use more labor hours than available, and it does not want to produce more than it can sell. The first question says, formulate PC Tech's production plan. Number 2, use simplex method to find the optimal net profit. Now, as you can see, the simplex method has more marks. It is given 20, it is allocated 20 marks. So which means there's a bit of work there. But our focus for today is specifically to formulate the PC Tech production plan. Now, there are a few things that we must know, what the question is wanting us to actually do. So let us review briefly what the question is requiring us to do. So what does the company want? Okay, that is the question we are asking ourselves. What does the company want? So we are told here that the company wants to know, okay, it wants to know how many, keyword here, how many of each models. How many models does it have? It has 2 models. So it has XP and it has basic, or it has basic and it has XP. So it has basic and XP. It wants to know how many of those models it should produce. Okay, it should produce. That is both to assemble and to test, so that what? The objective. What is the objective? So as to, what is the goal? Maximize its net profit. But we are told it cannot use more labor hours than available, and it does not want to produce more than it can sell. So it wants to keep it within the range. It does not want to overshoot its production. Now, how do you go about such a problem? So we have established what we want to know. We want to know how many of each computer it can produce. Now, the first thing you must do is, once you've known what the question is requiring you to do, then we can define our key variables. Okay, so from there we can define the key variables. So we can define the key variables. All right, so we can define the key variables. And what are the key variables? We want to know, it is the quantity of the computers this company should produce. And how many computers do we have? We have 2 computers. Okay, we have basic and we have XP. So it wants to know how many of each of these computers it can produce. So the way we define key variables is, we just say, since they want to produce these 2 types of computers, we are trying to look for the quantity. Okay, the quantity is what is the key in this question. It is the how many should they produce. Okay, it is the how many should they produce. Now, we are going to represent the quantity of basics as x1, and we are going to represent the quantity of XPs as xc2. So this is the first thing that we must do. If they had given us 3 computers or 3 types of computers, we could have said x1, x2, and x3, etc., etc. So that is how you go about this thing. So this is the first part that we have to do. Now, once we have done that, we can now proceed and actually start answering the question of how do we go about formulating the production plan. How do we formulate the production plan? Now, it's very easy. Remember, the objective will help us formulate our objective plan. The first thing that we want to find is our objective. And what is our objective? We have been told that our objective is to maximize what? To maximize net profit. So maximizing net profit is our net objective. And how do we represent our objective? We represent our objective as Z is equal to the key variable, which is x1 plus xc2. Okay, now these are the quantities. These x1 and x2 are the quantities. Z is for the profit. Okay, the profit. Now a profit is a number, and what we want to find, what this is wanting us to find, is how much net profit can we make from one basic computer and one XP computer. That is what we are trying to determine here in the first in the objective to maximize our net profit. It is how much does one computer make us, or how much profit does one XP and one basic make us. So to find the net profit, we know the formula. Okay, the formula is what is, how do you find net profit or profit in general? It is revenue minus cost. Revenue minus cost. that is how we find the net profit or profit. Now, have we been given the revenue and have we been given the costs? The answer is in the question. So we're going to go back and try to identify what is the revenue for basics and what is the revenue for XPs. Now, the way I love to do this is I love using a table. Okay, now I'm going to put my basic computers on top here, and I'm going to put my XP computers on top there. Then I can just draw a line like that and divide it in the middle. Okay, like that. Now we said we can present basic, the quantity, by x1, and XPs we can represent the quantity by x2. So these are pretty straightforward. Now the first thing I've said I would love to find is my revenue. Okay, so what is my revenue for one computer, or one basic computer, and one XP computer? That is what I'm trying to determine here. Now if we go back to the question and read the question, it is clear. What is the question telling us? The PCT company assembles and then tests two models of computers, basic and XP. For the coming month, the company wants to decide how many of each model to assemble and then test. No computer are in inventory from the previous month, and because these models are going to be changed after this month, the company doesn't want to hold any inventory after this month. It believes the most it can sell this month are 600 basic and 1200 XPs. Each basic, that is one basic computer, sells for $300. So I know the revenue from one basic, it is how much? 300 USD dollars. And each XP sells for 450 US dollars. So I'm going to put my 450 USD dollars here. Now the cost, okay, so now we have moved. You can notice the transition in the question. We have shifted from talking about the revenues. The question is shifting, or it is transitioning into the cost, automatically transitioning into the cost. So you can know that the formula we have is correct. So now we can even put our costs here. So the cost of component parts for a basic, so the first step of cost we have here are the cost of component parts. Okay, so the cost of component parts for a basic are 150 US dollars. Okay, so I'm going to write my 150 US dollars here. For an XP it is 225 USD. So XP it is 225 USD. Now this is the first cost that we have. They have told us also that labor is required for assembly and testing. Yeah, labor is required for assembly and testing. There are at most 10,000 assembly hours and 3,000 testing hours. So there are two types of labor there that we have, two types of labor costs that we are going to incur. So I can even say labor here. So what is the first type of cost? So we have assembly costs, and also we have testing costs in our question there. So we have assembly and the testing. Okay, then the question says there are at most 10,000 assembly hours and 3,000 testing hours available. Each labor hour, one labor hour each, that is one, let me say 1 LH. So one labor hour, okay, for assembling costs 11 US dollars. Okay, we can see it costs 11 US dollars. And each labor hour for testing one, let's write them here. So we're saying that 1 labor hour for assembling costs 11 dollars. Okay, in fact, let me do this so that people can see clearly what we are doing. So I'm going to say assembly here, and then I'm going to say testing here. This is just for our workings. Yeah, so they have told us that 1 labor hour for assembly costs how much? It costs 11 dollars. Okay, and 1 labor hour for testing costs 15 US dollars. Now the question proceeds further to say each basic requires 5 hours for assembling and 1 hour for testing. You see, so each basic, so I'm going to say each basic, one basic computer requires 5 hours for assembling, requires 5 hours for assembling, and 1 hour for testing. This same basic 1 hour for testing. Okay, 1 hour for testing. And each XP requires 6 hours for assembling. Each XP requires how many hours? 6 hours for assembling. So it requires 6 hours of assembling. And the question said 2 hours for testing. Yeah, now we can find the cost. It's easy. Once we break them down like this, it's very easy to now find the cost, because what we do now is basically multiply. We're going to multiply 5 by 11. This gives us 55. This is the cost of assembly for 1 basic computer. So we're going to say 55 here, US dollars. Then we can even do in advance for this is assembly. So I think I wrote testing as assembly is here, testing this side, and then 1 basic computer, the basic computer here, for testing, we only need 1 hour. So it will be 1 hour multiplied by $15. Sorry, $15. Yes, it will be 15 USC dollars. So we put a 15 US dollars here, like that. And then we come to our, we can put the symbols there, the currency signs, sorry. We come to XP. So 1 XP requires 6 hours for assembly. So just multiply 6 by 11. This gives us $66. So $66. And then we need 2 hours for testing. So it will be 2 by 15. So 2 by 15, we have 30. So 6 by 11 gives us the assembly hours, or the total assembly cost for 1 computer. And then we do 2 hours by 15. Remember, 1 hour, 1 computer requires for 1 hour. 1 labor hour for testing costs $15 across all computers. However, you only need 1 hour to assemble or to test a basic, and you need 2 hours to test an XP. So it will be 2 hours by $15 per hour. So this will be what? 30. Okay, so let's write it here, $30 US, like that. Okay, 30 USD. Now we can add to find our total. So we can find our total costs here first. So what will be our total costs? Our total cost will be 150 plus 55 plus 15 for the XP, for the basic, sorry. So it will be $250. And for the XP, it will be 225 plus 66 plus 30. This should give us so 225 plus 66 plus 30. This would give us 329. So these are the total costs. Now, what is our net profit per PC? So we basically deduct the revenue minus the cost. Revenue minus cost. So what is 300 minus 220? This is 80. You can even say 80 x1. Then 450 minus 321 gives us 129 x1. Okay, so therefore we're going to say our Z function, which is to maximize profit, is equal to 80x1 plus 129x2. Now the second part is subject to, we need to find the constraint. For you to be able to make this profit, there are a number of constraints that we have been given in the question. And the most fundamental ones, which we must begin with, have been given. They have told us the most fundamental ones, and I'm going to read them. Here the question says, let's grab our pen. The question says there are at most 10,000 assembly hours and 3,000 testing hours available. Okay, available. Each labor hour for assembling costs $11, and each labor hour for testing costs $15. We have already handled this. Now each basic requires 5 hours of assembling. Okay, now remember the cost here we have is what? For assembly. So I'm going to do this. I know that the first constraint I have is my assembly hours. These are limited, okay? They're not in everlasting, they're not perpetual. That's the first one. How many are they? 10,000. So I have 10,000 given assembly hours. I've also been given 3,000 testing hours. So this is a testing hours constraint. Testing hours constraint. Okay? Yeah, so there are 3,000 testing hours available. Now each labor hour, we have said for assembling cost 11, and each labor hour for testing costs $15. Now the key is here. One basic computer requires 5 hours for assembling and 1 hour for testing. Now here is the trick to answering these questions. You see, we need to find the number of hours so that we don't exceed 10,000 hours. Well, if we are going to produce both basic and XPs, we only have so much hours, and the total number of hours we have for assembling both basic and XPs are 10,000 hours. So at most means the maximum you can go. So meaning you should produce equal to or less than or equal to, as we say it. So we need to produce less than or equal to 10,000 of the we must use 10,000 or less hours. Same thing with our testing. we can only use 3,000 or less. Okay, that is how we do it. Now they have told us that each basic requires 5 hours of assembling. We need to find the total number of hours we are going to spend assembling basic computers. Okay, so this is the total number of hours per computer to assemble times the number of computers, the quantity, will give us the total number of hours we can spend on assembling one basic, plus the number of hours, and each XP requires 6 hours for assembling. So we also need to find the total number of hours we're going to spend assembling one XP computer. So we are done with assembly hours. We can now come and look at the testing hours. Now the testing hours, we have already been told that each basic requires 1 hour for testing. So 1 hour for testing, you can even say 1x1, or leave it blank. I remove the 1. It will be x1, just x1. So let's do this. We're just going to keep our x1 here. Okay. So we're going to keep our x1, then say plus. How many hours do we need to test the XP? We need 2 hours. So it will be plus 2 x2. Okay. Now these are not the only constraints we've been given. These are the most important constraints perhaps that we have in the question, but they are not the only constraints that we have been given. Now if we read the question again and we find numbers, it says no computer, I'm reading from here, right there, no computers are in inventory from the previous month, and because these models are going to be changed after this month, the company doesn't want to hold any inventory after this month. It believes it believes the most it can sell this month are 600 basic. The most it can sell are 600 basics and 1,200 XPs. So it can only sell less than or equal to 600 for the basics. Okay, so these are the basics constraint, and it can sell 1,200 for the XPs. So these are the sell XP sales limit, and you can see the same thing, basics sales limit. So just say x1 here and x2 there. And the last thing we're going to do is our non-negativity constraint. Please don't forget this. It is x1 comma x2 greater than or equal to 0. Then we say non-negativity constraint. It means it is not possible to produce negative 1, negative 2, or negative whatever number of XPs and number of basic computers. So this is where we end our session for today. When we come next time, we are going to continue with our part B of the question, where we have been requested to use the simplex method to find the optimal profit. Thank you very much for joining in this session. May God bless you and all the best. Thank you very, very much.